You know, when you think about the biggest living things on Earth, your mind probably jumps to something like a blue whale. But get this, the largest trees can weigh almost 2,000 tons. That's the same as 10 blue whales, and they can stretch 25 stories into the sky. And it all starts from one tiny little seed. So, how? I mean, it seems pretty obvious, right? Trees are solid, the ground is solid. They must just be sucking up all that mass from the soil. It's the logical assumption to make.
But just think about that for a second. If something that enormous was literally eating the earth beneath it, you'd expect to see a massive crater, right? But you don't. So, what is really going on? Well, the answer is way more incredible than you might think.
That's right. The vast majority of a tree's weight, all that wood, the bark, the leaves, it isn't built from the soil. It's built from the air itself. A tree literally eats the sky. And believe me, that's just where this amazing story begins. Okay, so to figure out how a tree pulls off this incredible trick, we have to look up, way up, into its crown. Now, this isn't just a random bunch of leaves. It's a super sophisticated biological city, and it's built for one main reason: to harvest carbon, the most valuable building block for life, straight out of the atmosphere. And you can see here just how ridiculously good they are at it. Plants make up a staggering 80% of all living mass on our entire planet. Everything else, that's us, all the animals, fungi, bacteria, we're just the other 20%. Plants are the foundation that all complex life is built on. But here's the catch. The one ingredient they absolutely need, carbon dioxide, makes up this tiny fraction of the air, just 0.04%. Imagine trying to build a skyscraper, but your main building material is just scattered around like a little bit of dust in the wind. That's the challenge a tree wakes up to every single day. And just look at the scale of this job. To get 1 single ton of carbon, a tree has to filter through 5 million cubic meters of air. That is an almost unbelievable volume. So how on earth does it solve this massive engineering problem? Simple. It builds a factory. A massive, sprawling, solar-powered factory network. The crown of a tree, with its hundreds of thousands of leaves, is basically a giant industrial park designed to sift through colossal amounts of air with incredible efficiency. And if you zoom in, each individual leaf is like a perfectly designed factory floor. You've got this transparent outer skin to let the sunlight pour in. Then there's the factory layer, packed with all the machinery, the chloroplasts. Below that, a spongy layer so gases can move around. And on the bottom, hundreds of thousands of tiny adjustable mouths called stomata that literally breathe in the CO2. And all of that amazing machinery is for one process: photosynthesis. This is where the magic happens. It uses the energy from sunlight to smash together carbon dioxide and water to create glucose. And this simple sugar is everything. It's both a battery to power the tree and the actual building block for making more tree. Now, to keep these little sun-drenched factories from overheating, a tree needs a really powerful cooling system. So it's constantly pulling up huge amounts of water from its roots, and an incredible 95% of that water is just sweated out through the leaves to stay cool. In fact, a whole forest can release so much water vapor it can actually create its own rain clouds. So we've seen how the tree builds this incredible empire in the sky, pulling its very substance out of thin air. But everything we've talked about so far, well, it's only half of the story. To understand the rest, we have to go underground. Because right beneath our feet, there's a second, invisible crown, the root system. And it's an empire that's just as complex and just as active as the one in the sky, but it's on a completely different and equally vital mission. So first off, let's just bust a really common myth. We all kind of picture tree roots as a mirror image of the branches, just plunging deep down into the earth. But the reality is usually totally different. Most of a tree's roots are actually a dense, tangled mat in just the top layers of soil, spreading out super wide to catch rainwater the second it hits the ground. But roots do so much more than just drink water. They are active miners, constantly hunting for rare minerals like phosphorus and nitrogen that the tree needs to survive. They have to navigate this chaotic underground maze of rocks and other roots, and sometimes they even have to break right through solid stone to get what they need. So how do they navigate this crazy maze? Well, every single root tip is fitted with something called a root cap. It's basically a sophisticated little command center. It can sense gravity, so it knows which way is down. It can detect moisture and chemicals in the soil, and it processes all that data to make smart decisions about where to grow. A single tree has hundreds of thousands of these tiny brains. And they are incredibly powerful. A root can find a tiny crack in a rock, force its way in, and then pump itself full of water, generating enough hydraulic pressure to split that rock wide open. Once it's inside, it can release special acids that literally dissolve the stone to unlock the precious minerals trapped inside. But here's the thing. Even with all that incredible power and intelligence, a tree doesn't work alone. To really thrive, it forms one of the most important partnerships in the entire natural world, creating a network that people have started calling the wood wide web. The tree's most important allies are fungi, and they strike this beautifully simple deal. The tree, which is rich in sugar from all its factories up in the sky, trades that energy with the fungi. In return, the fungi, who are the masters of the underground, provide the tree with water and all those hard-to-get minerals. It's a perfect partnership. And this is why the deal is so good for the tree. The fungi give it reach. Their microscopic little threads are so unbelievably fine that they can slip between individual grains of soil, exploring tiny pockets of water and nutrients that are completely off limits to even the finest tree roots. The scale of this network is it's mind-boggling. In a single cubic meter of healthy forest soil, so about a 3-foot cube, you might find several kilometers of tree roots. But woven all through that same soil, you could find hundreds of kilometers of these fungal networks. It's not even close. And this network just keeps getting bigger. It doesn't just serve one tree. It connects to other trees and their fungi, knitting the entire forest together into this single, vast, interconnected system where resources and maybe even information can be shared. So when you look at a tree, what are you really seeing? You're seeing these two massive, incredibly complex empires. One that's reaching for the sky to literally build itself out of the air, and another that's exploring the dark earth, mining solid rock, and forming ancient alliances. And together, they form one spectacular organism. A tree isn't just a passive chunk of wood. It's this active, dynamic, mind-bogglingly complex living thing. It's a city in the sky and an empire under the ground, working with a hidden fungal kingdom. It is truly one of nature's greatest marvels. And the most amazing part of all is that we are just scratching the surface of how it all really works.